The Voyager spacecraft are now disclosing new and terrifying revelations from the depths of space. Originally intended for a mission lasting only 5 years, NASA's Voyager probes have exceeded all expectations, continuing their trek across unexplored regions of the cosmos for nearly 45 years. Recently, Voyager 1 communicated some puzzling data back to Earth, leaving astronomers confused. In this video, we will investigate these fascinating finds and the surprising insights they may hold. Voyager 1 was launched into space on September 5, 1977, from Cape Canaveral, Florida, using a Titan III Centaur rocket. This was the beginning of an incredible adventure. Only 15 days earlier, on August 20, 1977, Voyager 2 had already set off on its own space exploration journey. The primary mission for these twin spacecraft was initially to explore Jupiter and Saturn, the gas giants of our solar system, as well as their moons. However, these daring adventurers went far beyond their original objectives, embarking on a voyage that would take them to the farthest corners of our cosmic neighborhood. The Voyagers have broken numerous records during their historic mission, having outlasted every other spacecraft in history. They have traveled farther from Earth than any other human-made object, reaching into interstellar space, the first objects created by humans to explore portions of the galaxy yet unknown to science and beyond the Sun's influence. Scientists have gathered an immense amount of priceless data from these groundbreaking probes, which are now located more than 12 billion kilometers from Earth. Their discoveries continue to astound physicists. One particularly amazing and unexpected discovery, which scientists could never have imagined, will be discussed later. Over the past 40 years, the twin Voyager probes have made remarkable contributions. One of their most astonishing discoveries was the presence of moons around Jupiter and Saturn, which shocked scientists and upended prior assumptions about these distant planets. Contrary to earlier beliefs that these moons would be lifeless and cratered like our own moon, they were found to be geologically active, teeming with activity. Voyager 2 also achieved several noteworthy milestones during its journey. In 1986, it became the first spacecraft to sail past Uranus, and 3 years later, it flew past Neptune. The wealth of knowledge it provided included revelations about Neptune's ferocious winds, icy volcanoes on Triton, and the previously undiscovered moons of Uranus. NASA has implemented multiple procedures to extend the operating lifespan of the spacecraft. By turning off heaters and non-essential parts to save energy, the spacecraft will continue to operate for at least the next 10 years. The mission is expected to conclude around 2030, but this meticulous management guarantees that they will continue to send back data for as long as possible. For the scientists and engineers involved in this incredible journey from the beginning, the end of the Voyager mission is a moment of mixed emotions. Their dedication and tenacity have resulted in a mission far more successful than anyone could have imagined, leading to numerous scientific advances and significant new understandings of our solar system and beyond. The data gathered by the Voyagers have inspired future generations of scientists and space enthusiasts. Before their launch, no one could have predicted how the Voyagers would revolutionize our knowledge of the solar system. Their missions revealed secrets such as the frozen shell of Europa, the towering volcanic plumes on Io, one of Jupiter's moons, and the stunning discovery of Jupiter's thin rings. The lively and active worlds captured in the images and data returned by the Voyagers contrasted sharply with previous notions that these regions were lifeless and desolate. Voyager 2's journey continued to yield groundbreaking discoveries as it ventured farther into the outer planets, including the discovery of 10 previously unknown moons around Uranus and Neptune's extreme weather, where winds reached speeds of 1,000 miles per hour and surface temperatures dropped to -391 degrees Fahrenheit -235 degrees Celsius. One of the coldest places in the solar system, Triton, Neptune's largest moon, surprised scientists with its ice volcanoes, which release frozen particles and nitrogen gas. As Voyager 2 continued its exploration of the outer planets, Voyager 1's path brought it dangerously close to Saturn's moon Titan. There, it uncovered a hazy orange atmosphere and complex chemistry, raising new questions about these distant worlds with every encounter. Each discovery challenged preconceived ideas and produced a wealth of data. Voyager 1 and Voyager 2 were no ordinary spacecraft. Their precise design allowed them to rotate at a rate 15 times slower than the hour hand of a clock, which minimized visual blur and provided stable platforms for collecting data and taking pictures as they sped through space. Even months before reaching the outer planets, their impressive imaging capabilities started to amaze both scientists and the public. As they approached Jupiter, they began transmitting pictures of the planet's whirling clouds, an iconic Great Red Spot, thrilling viewers at NASA's Jet Propulsion Laboratory. However, the real catalyst for their groundbreaking observations was the discovery of active volcanoes on Jupiter's moon Io, making it the most volcanically active body in the solar system. The Voyager missions changed our understanding of the outer planets and their moons. One of the most surprising discoveries was that Europa, one of Jupiter's moons, may have an ocean beneath its icy surface, sparking interest in the possibility of extraterrestrial life. Similarly, geysers flowing from Enceladus, Saturn's moon, suggested the potential for liquid water beneath its surface. These discoveries have sparked follow-up missions to learn more about these fascinating moons and their potential for hosting life. The experiences of Voyager 2 with Neptune and Uranus were equally revolutionary. As the probe approached Uranus, it discovered that this seemingly featureless blue-green planet had many moons, including the geologically active Miranda, and a complex magnetic field. In 1989, Voyager 2 sent back humanity's first detailed photographs of Neptune, revealing its vibrant atmosphere, deep blue color, and great dark spot. The spacecraft also discovered that Neptune had weak rings and 6 additional moons. As the Voyagers traveled deeper into space, their instruments continued to send back critical scientific data. One of their most important contributions was information about the heliosphere, the bubble-shaped region dominated by the Sun's magnetic field and solar wind. After crossing the heliopause, which marks the boundary of the heliosphere, the Voyagers entered interstellar space, providing data on the sparse environment between the stars. One of the most astonishing findings was the unexpected increase in cosmic rays in interstellar space, which has led scientists to rethink their theories about the interstellar medium. The longevity and success of the Voyager missions are a testament to the creativity and dedication of the scientists, engineers, and technicians who designed, built, and operated the spacecraft. Despite the extreme conditions and vast distances traveled, the Voyagers have continued to operate, sending back data that has revolutionized our understanding of the solar system and beyond. The missions also highlight the critical role of robotic exploration in advancing our knowledge of the cosmos. As the Voyager missions near the end of their operational lives, NASA has implemented policies to conserve the spacecraft's energy and extend their missions as long as possible. With careful energy management and the shutdown of non-essential systems, the spacecraft are expected to continue sending back data until at least 2030. The data gathered during this time will greatly enhance our understanding of the interstellar medium and the outermost regions of the solar system. Beyond their scientific contributions, the Voyager missions leave behind a lasting legacy. Each spacecraft carries a golden record containing audio and visual representations of life and civilization on Earth. This symbol of humanity's reach into the cosmos will endure long after the spacecraft have stopped sending back data. These documents are a message to any future extraterrestrial civilizations that could come across the spacecraft. The Golden Record's presence reflects humanity's interest in and desire to establish connections with the larger cosmos. The Voyager spacecraft's breathtaking images confirmed the odd signals picked up from Io. These photos showed a dynamic terrain characterized by towering volcanic plumes and the discharge of volcanic debris. Pele, a well-known volcano on Io, is one of its most spectacular characteristics, with eruptions reaching heights 30 times higher than those of Mount Everest, covering an area about the size of France. Over 33,000 images of Jupiter and its moons were taken by the Voyager spacecraft, demonstrating the grandeur of the planet and the remarkable diversity of moonscapes in the Jovian system. The twin Voyagers have continued to make groundbreaking discoveries since their launch. One of the most unexpected discoveries was that Jupiter had rings, although faint. These rings added to the mystery surrounding the gas giant. Earlier theories concerning these far-off celestial entities were also questioned when Voyager 2 discovered that Europa, one of Jupiter's 53 named moons, had an icy crust more than 60 meters thick. This discovery opened new directions for planetary science research by enticing scientists to explore the possibility of ice moons being habitable. Following their mission at Jupiter, the Voyagers received a vital gravity boost that gave them the final push towards Saturn. Without this essential boost, they would never have been able to break free from the gravitational pull of the Sun and continue their journey deeper into space. Soon after, Voyager 1 and Voyager 2 split up, each traveling into uncharted territory. Voyager 1's trajectory brought it very near Titan, Saturn's moon, which is enveloped in a thick orange atmosphere. Scientists' curiosity about Titan's mysteries led to further research into its intricate composition. After this encounter, Voyager 1 moved north, leaving the planetary system and beginning its ascent out of our solar system. Meanwhile, Voyager 2 embarked on an extraordinary journey to the outermost planets of the solar system. It made a landmark flyby of Uranus in 1986, discovering 10 previously unknown moons, thereby expanding the known number of satellites orbiting the planet. 3 years later, Voyager 2 reached Neptune, revealing amazing features of this distant ice giant. During its approach, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, the fastest winds ever measured on any planet in the solar system. As it approached Neptune's methane-laden azure atmosphere from a distance of 2,980 miles, the spacecraft provided unparalleled insights into this distant planet. It was discovered that Triton, Neptune's largest moon, is one of the coldest places in the solar system, with surface temperatures dropping as low as -391 degrees Fahrenheit. Triton also exhibited unusual geological features such as ice volcanoes that erupted up to 5 kilometers into its thin atmosphere, spewing frozen particles and nitrogen gas. These discoveries greatly expanded our understanding of the diversity and complexity of celestial bodies, even in the farthest reaches of our solar system. In addition to increasing our knowledge of the outer planets and their moons, Voyager 1 and Voyager 2 have provided invaluable data during their interstellar journeys. The culmination of their studies of the heliosphere, a vast bubble-shaped region of space dominated by solar winds, came when they crossed the heliopause, the point where interstellar space begins and the solar wind's influence fades. In 2012 and 2018, Voyager 1 and Voyager 2 became the first human-made objects to enter interstellar space. This transition advanced our understanding of the boundary between our solar system and the rest of the galaxy by providing scientists with abundant information on the characteristics of magnetic fields and interstellar plasma. Triton, Neptune's largest moon, not only ranks among the coldest locations in the solar system but also presents intriguing phenomena such as nitrogen gas geysers erupting from its surface. These geysers, similar to those on Io, suggest that Triton experiences tidal heating, hinting at an internal heat source that keeps its surface active despite the extremely cold temperatures. During its encounter with Neptune, Voyager 2 also discovered the planet's faint rings. 2 notable rings, named Adams and Leverrier after astronomers John Couch Adams and Urbain Leverrier, were confirmed to exist, as well as 4 ring arcs and 3 additional rings surrounding Neptune. These rings, composed of rock and dust, partially encircle the planet. Despite their fragility, these arcs do not scatter into space as expected, and their origin and stability remain a mystery, adding to the intrigue surrounding Neptune's ring system. Voyager 2's journey to Uranus also revealed 10 new moons orbiting the planet, offering the first up-close images of its moons and discovering that Uranus' magnetic field is unusually oriented away from the planet's core. This magnetic field is tilted at a sharp angle relative to the planet's rotational axis, creating an extremely asymmetric and dynamic magnetosphere. These discoveries sparked greater interest in the planet's complex magnetic environment. The data collected by both Voyager spacecraft has had a significant impact on our understanding of the outer planets and their moons. They provided the first comprehensive examinations of these distant worlds, revealing complex ring systems, active geological processes, and dynamic atmospheres. The discoveries made by the Voyagers have inspired a new generation of scientists and paved the way for further exploration. As for Neptune's outer rings, scientific theories suggest that their gravitational pull confines the arcs and maintains their structure. Voyager 2 continued its journey beyond our solar system after completing its mission at Neptune, following Voyager 1, which entered interstellar space in 2012. Voyager 2 made this transition in 2018, cementing its place in history as the first and only spacecraft to conduct an extensive study of Uranus. During its 1986 flyby, it discovered 2 rings around Uranus, including the elusive Zeta ring. This ring disappeared shortly after its discovery and remained unseen for over a decade. However, in 2022, NASA obtained an updated image of Uranus from Voyager 2, which revealed the Zeta ring once again. The new data allowed scientists to estimate the distance between Uranus and its rings to be around 37,000 kilometers. Intriguingly, the Zeta ring appeared quite different from its 1986 discovery, and NASA scientists, led by Chief Observer Matthew Hedman, noted significant changes in the ring's structure. Although the reasons for these changes are still unclear, the leading hypothesis is that seasonal changes on Uranus may be affecting the ring's visibility, adding to the mystery surrounding the outer planets. Since its launch 45 years ago, Voyager 1 has continued to provide critical data. In 1990, NASA launched the Voyager 1 interstellar mission, during which the spacecraft took nearly 67,000 photographs, giving scientists a wealth of information. As Voyager 1 moved farther away from the Sun, NASA turned off its cameras to conserve power, but the spacecraft continued to transmit non-visual data using the Deep Space Network, DSN, a system of massive radio antennas. In 2012, Voyager 1 left the Solar System and entered interstellar space, traveling at 6,197 km per hour. It continues to send back valuable signals that shed light on this vast, largely uncharted region. Through its journey into interstellar space, Voyager 1 has provided crucial information about the heliopause, the point where solar winds lose their influence and the interstellar medium begins. This data has greatly enhanced our understanding of the solar system's outermost regions and the boundary between our solar system and the galaxy. This knowledge has been essential to comprehending the makeup of the interstellar medium. The density, temperature, and pressure of the plasma in this area have been recorded by the spacecraft sensors, providing insights into the characteristics of interstellar space and its interactions with the heliosphere's outermost regions. The voyage of Voyager 2 has been just as life-changing. Its flybys of Neptune and Uranus gave us the first up-close looks at these far-off planets and their moons. Voyager 2 found that the day on Uranus is just 17 hours long and that hydrogen and helium make up the majority of the planet's atmosphere. The spacecraft also observed Uranus's distinct magnetic field, which is extremely asymmetric and dynamic due to its substantial tilt and offset from the planet's core. Voyager 2 found numerous ring arcs and 5 rings at Neptune. Surprisingly, these arcs are collections of boulders and dust that do not disperse as one might anticipate. Rather, they continue to be grouped, which goes against the accepted wisdom about ring dynamics. Neptune's ring system is mysterious in part because the exact causes of its development and stability are still a mystery. Unprecedented information on Triton, Neptune's biggest moon, was also made available by Voyager 2. It was discovered that Triton is geologically active, as evidenced by the eruption of nitrogen geysers from its surface, suggesting that, similar to Io, it is heated by tidal forces. Given Triton's extremely cold temperatures, this discovery was surprising and provided fresh information on the geological processes that may take place on ice worlds. Our knowledge of the outer planets and the larger solar system has substantially increased thanks to the 2 Voyager probes. They have discovered dynamic atmospheres, intricate ring systems, and active geological processes. They keep sending back data as they go farther into interstellar space, expanding the frontiers of human understanding. Long after the Voyager instruments are silent, their legacy will live on. They stand for the persistent spirit of discovery and humanity's thirst for adventure. Their enormous contributions to science have inspired generations of scientists and engineers to aim for the stars and laid the groundwork for upcoming expeditions. Even the world's top scientists are baffled by the increasingly confusing signals from Voyager 1 in recent times. The present broadcasts from the spacecraft cannot be decoded, in contrast to the clear data it used to deliver, data indicating that Voyager 1 is unsure of its position in interstellar space. Adding to this peculiar turn of events, NASA's Deep Space Network, DSN, would normally detect this kind of information automatically. One of the many elaborate plans NASA had for the Voyager missions was to outfit Voyager 1 with a unique alarm system that would sound if the probe became lost in space. But despite the jumbled signals, this alarm hasn't gone off. This suggests that although it appears disoriented, the spacecraft has not, in fact, gotten lost. Additionally, NASA has verified that the antenna on Voyager 1 is operational and continues to be positioned appropriately for communication with Earth. The fact that the spacecraft is still receiving and carrying out directions from NASA suggests that returning data transmission is the issue rather than data reception. Another layer of mystery surrounds Voyager 1, as NASA experts are certain that the signals it sends do not adequately represent its true state in space at the moment. Signals sent to and from Voyager 1 take around 2 days to reach their destination. Given this considerable delay, it is unclear what is going on with Voyager 1 and why the spacecraft's most recent transmissions seem so strange. There are several theories, one of which is the fascinating theory that Voyager the 1st of May have come into contact with extraterrestrial life. Like other NASA spacecraft, Voyager 1 is equipped with a unique golden-plated disc called the Golden Record. This disc includes multilingual audio and video messages, along with a wealth of information about mankind. The purpose of these signals was to alert any extraterrestrials that the spacecraft could come into contact with, though the scientists acknowledged that we have no clue what language, if any, they may speak. To boost the possibility that any aliens might interpret the material, the scientists provided many translations. There is yet no solid proof that Voyager 1 has come into contact with extraterrestrial life. Nonetheless, the inexplicable signals it is transmitting could indicate that it has interacted in some way with an unidentified creature. In the past, NASA has overlooked important findings, like the galaxies at the end of the cosmos that the James Webb Space Telescope just recently discovered. The idea that Voyager the 1st of May have come into contact with alien intelligence, which may be attempting to answer by utilizing the information on the Golden Record, is strengthened by this history of overlooked events. The possibility that aliens are using Voyager 1 to try to make contact with humanity is both exciting and terrifying. It raises several concerns over the type of signals being relayed back and the power and purpose of the alien beings. Do they get along? Are they only interested in us? Or are they perhaps dangerous? NASA's present efforts are directed at interpreting these anomalous signals and determining whether Voyager 1's systems have malfunctioned. To ascertain whether the abnormalities are the result of external influences or technological failures, a thorough study of the data is required. Scientists are forced to rely entirely on the signals and data they receive because direct involvement is not feasible due to Voyager 1's great distance from Earth. The fact that Voyager 1 has been passing through a part of space that is mostly unknown to us only serves to complicate matters. Conditions in interstellar space are extremely unlike those in our solar system, making it a hostile place. The spacecraft's instrumentation and data transmission capabilities may be impacted by events it is experiencing that we have never seen before. Exploration and discovery have always been the goals of Voyager 1. It has provided priceless information on the outer planets and the furthest reaches of our solar system ever since it was launched. It is currently expanding our understanding as it travels deeper into interstellar space. The enigma surrounding its signals at the moment highlights the inherent unpredictability and surprises of space travel. The Voyager 1 Odyssey continues to demonstrate the tenacity and inventiveness of human engineering. The spacecraft is still an essential source of information, even after all these years and the vast distances it has covered. The difficulties it encounters serve as a reminder of the size of the cosmos and the amount of knowledge that remains. Regardless of whether Voyager 1 has found extraterrestrial life, its mission continues to enthrall and motivate us in our pursuit of understanding the universe. Ideas are circulating among those who suggest that Voyager 1 is currently under extraterrestrial control. NASA also takes into account the great distance that Voyager 1 is currently traveling. Voyager 1 is the farthest object created by humans, having traveled a record-breaking 23 billion kilometers beyond Earth. When building its communication systems, NASA did not initially consider the potential that the ship might go such a great distance. It is therefore possible that Voyager 1's communication technology was not designed to transmit data across such vast distances. These are only conjectures. Nobody is certain of what is taking place. The actual problem is that the Voyager spacecraft cannot be recalled. Its RTGs, radioisotope thermoelectric generators, must be used until their batteries run out. Voyager 1 is projected to stop operating once the RTGs continue for a further 3 to 5 years. Furthermore, there is no practical means of accessing the spaceship to perform any maintenance or repairs. Voyager 1 took 45 years to reach its current location, making it impossible for any vessel to reach there in that amount of time. All we can do is hope that aliens have not occupied our beloved Voyager 1 and wait for a breakthrough. Maybe in the future, the question of what message the aliens are attempting to relay remains, assuming they are genuinely sending these signals. The Voyager 1 and the unanswered questions it raises highlight the amazing success and constraints of human space travel. The spacecraft's current situation shows how much more we still need to learn, even though it has yielded priceless data about our solar system and beyond. There are several possible explanations for the signals it is returning, such as technological issues, the great distance, or interactions with unidentified interstellar phenomena. Despite these difficulties, Voyager 1 is still in operation and is returning data that may provide further insight into the workings of space exploration for scientists. Even in its advanced years, the spaceship is still committed to expanding human understanding as part of its original purpose. Though theoretical, the notion of aliens communicating with Voyager 1 sparks curiosity and emphasizes the immense uncharted territory of space. Any intelligent species that could come across the spaceship, remember to subscribe to our channel and use the like button for more content.